boys and girls. I am Erica Allen Charles, and welcome to today's maths session. Today we are going to be looking at mass. Funny word? Think of weight. Have you ever measured your weight? What would you use? What about those who have gone to the market? Have you ever wondered what's going on there in terms of the weight of the fish or the weight of the tomatoes? It's also mass. So from today, we're going to use that word, mass. I want to show you something in front of me. This is called an equal arm balance. Inside of each one, I have 4 cubes. 4 cubes on this side, 4 cubes on this side. Well, because 4 cubes on this side and this side, it's balancing. So that's why it's called an equal arm balance. You have to have the same quantity on both sides. I wonder what would happen if I were to remove one of the cubes. Do you think you know? Let's try it. How many knew that was going to happen? Yes, this side went down because the weight or the mass, as I'm saying, is now greater on this side as I have removed one of the cubes. Isn't that interesting? So we're going to go on now. Now, the standard unit for measuring mass is the gram. And then you have the kilogram, heavier weights. What about the gram? What about a copybook? What unit do you think we could use to find the mass of a copybook? If you said grams, you are absolutely correct. Yes, because a copybook is heavier than that of a tiny tablet. What about a bag of flour? I wonder. What do you think would be the most appropriate unit to measure the mass of a bag of flour? Kilograms. Correct. You're catching on. So we are seeing now that we can use different units for different masses. All right. Can I challenge you a little bit? What if I call out now some objects and you tell me what would be the appropriate mass unit to use? Let's try. A loaf of bread. What do you think you would use to find the mass of a loaf of bread? If you said grams, I think you're on point. Very nice. Cell phone. Yes, same thing. Grams, you are absolutely correct. What about a car? Would you use grams to find the mass of a car? I think not. We would use the kilogram. It's not a toy car, you know. I'm talking about the cars on the road now. All right. So you're catching it. You are catching on. Now I want to take you a little further. I want to introduce you to a conversion chart involving mass. Come with me now. This is our conversion table. It says 250 grams is equal to 1/4 kilogram. 500 grams is equal to 1/2 kilogram. 750 grams is equal to 3/4 kilogram. And 1,000 grams is equal to 1 kilogram. Are you seeing it? Are you seeing a pattern there? Bear this in mind, you know, because we're going to be using this conversion table to solve some problems. All right, question number 1 now. Let's read together. Come with me now. Mommy used 2 1/4 kilograms of flour to make bakes. How many grams did she use? Let's read it again. Mommy used 2 1/4 kilograms of flour to make bakes. How many grams did she use? Let's go to our conversion table. Are you seeing anything there? Yes, I am seeing the 1/4 kilogram. Are you not seeing that there? Yes, and 1/4 kilogram is equal to 250 grams. So we know that already. 2 kilograms. But when I look at my conversion table, I am seeing that 1 kilogram is equal to 1,000 grams. So how many grams do you think would be equal to 2 kilograms? Yes, 2,000. Let's put that information down now. I'm going to write down the information that is given. I am going to break this down. Are you seeing what I did? 2 1/4 kilograms is equal to 2 kilograms plus 1/4 kilogram. Now we can go further. What did I say before? The 2 kilograms is equal to what? 2,000 grams. So let's write that down. And we are adding what? Are you going to bring down the 1/4? Let's go to the chart. 1/4 kilogram is equal to 250 grams. So now we are bringing everything to the same unit. Are you seeing that? So I'm going to write 250 grams here now. When I add my 2,000 grams to my 250 grams, what will I get? Correct. 2,250 grams. Well done, boys and girls, well done. Question number 2. Read with me now. Tom used 6,300 grams of cement to make a plant pot. How many kilograms did Tom use? Let's read it again. Tom used 6,300 grams of cement to make a plant pot. How many kilograms did Tom use? Let's pull out the 6,300 grams. Let's go to the conversion table. Are you seeing anything there? Are you seeing anything with thousands? When I look at it, I am seeing that 1,000 grams is equal to 1 kilogram. Are you seeing thousands there? Yes, 6,000. Could we pull that out and separate it from the rest of the number? I know that you're trying to figure out how many kilograms they are, and I know that somebody has it already. So let's separate. Are you seeing it with me? Are you seeing why I pulled out the thousands there? Yes, because now I can convert the grams to kilograms. Can you do it with me? How many kilograms are there in 6,000 grams? Yes, 6 kilograms. Well done. But if you look very carefully, we have 300 grams remaining. Isn't that less than 1,000? When we look at our conversion table, all the numbers that are less than 1,000, fractions. So guess what we're going to do? We're going to represent that 300 as a fraction of our whole. 1 kilogram is equal to 1,000 grams. So we're going to represent it as a fraction now. Look at me now. Children, are you seeing it? Are you seeing it? Let's reduce now. So we are left with 3/10 kilogram. Let's put them together. What is going to be our final answer? Let's look at it. Six and 3/10 kilogram. Children, are you seeing it? Well done. Now I'm going to challenge you a little bit more. I am going to give you a problem where there is a picture attached. That picture is very, very important. So we are going to read the question and then look at the picture and see if it helps us to solve the problem. Ready? Let's go. There are 5 oranges on a scale. What is the weight of each orange if each has the same mass? Let's look at the picture. Are you seeing a similarity to the equal unbalance I showed you earlier? Remember what I said? Once they are the same, they will balance. They look like they balance to me. Let's first count the number of oranges. Count with me now. 1, 2, 3, 4, 5. There are 5 oranges. And remember, when we look at the question, it says each has the same mass. So we know that each orange has the same mass. That is very, very important. All 5 oranges together have a mass of 2 kilograms. How are we going to find the mass of 1 orange? I'm seeing you thinking there, you know. What can we do? Well, first, we can pull out the 2 kilograms, can't we? Let's do something with that now. What if we change our kilograms to grams? 2 kilograms will give us how many grams? Yes, 2,000 grams. So far, so good? But we want to find out the mass of 1 orange. All 5 oranges together have a mass of 2 kilograms, which is equal to 2,000 grams. How do we find the mass of 1 orange? I wonder if you know what to do. I wonder if you know what to do. Yes, yes, yes. I'm seeing people with their pencils now. We are going to divide. Divide the 2,000 grams by what? What number are we going to divide by? Oh, yes. We are going to divide by 5. Why? There are 5 oranges with the same mass. Let's do that together now. Can we do anything here? Let's go. 5 into 5, 1. 5 into 24. So in fact, the mass of 1 orange is 400 grams. Do you know you can check back to make sure that you are correct? What if I multiply the 400 grams by 5? Will I get back the 2,000 grams? Yes. 400 grams multiplied by 5 will give me my 2,000 grams, which was equal to 2 kilograms. You are correct. Well done. All right, so let's look at another question now with another picture. Read the problem with me. How many grams must be removed from A to make the scale balance? Let's read it again. How many grams must be removed from A to make the scale balance? Let's look at A. A has a mass of 2.4 kilograms. On the other side, we have 2,000 grams. A is heavier than the other side. Look at the question. How many grams must be removed? For us to solve this problem, a number of grams must be removed to make it balance. The question is, how many grams? But if you look carefully, we would realize that we have 2 different units. 2 different units. What if we change 1 to the next unit so that we can compare? Let's try that. So we're going to look at the 2.4 kilograms and we are going to change that to grams so that we can compare. All right, so let's pull out the 2 4/10 kilogram now. All right. How many grams are there in a kilogram? Let's go back to our conversion table. 1,000 grams. So 1 kilogram is equal to 1,000 grams. How many grams will we find in 2 4/10 kilogram? Remember, we are multiplying by 1,000. So we'll get 2,400 grams. Wonderful. So now we can say 2,400 grams, which is A. We can take away 2,000 grams to see what is the difference. Remember, what number of grams must be removed. Let's subtract. And what is the answer now? 2,400 grams, take away 2,000 grams will give us 400 grams. Well done, children. That's the answer there. So 400 grams must be removed for our scale to balance. Which of the following is the best buy? We are purchasing pigeon peas. Pigeon peas, 5 kilograms for $18. Pigeon peas, 6 kilograms for $21. Pigeon peas, 8 kilograms for $24. Which one do you think is the best buy? You know, some of you will say 5 kilograms for $18. How are we going to find out which one is the best buy? Do you know what we have to do? We must find for 1 kilogram for each one of these. What is the value of 1 kilogram of pigeon peas for each one? So what are we going to do? Let's take them one at a time. 5 kilograms of pigeon peas for $18. How are we going to find out for 1 kilogram? What? Yes, yes, yes. We are going to divide. So let's do that now. Let's divide. 5 into 18. I'm going to put my dollar sign. 3. Remainder 3. 5 into 30. 6. Let's put our decimal point. 5 into 0. 0. So the first one, 1 kilogram is $3.60. Let's try the second one. Let's go. Putting our dollar sign. Remember, very important. How many 6s are there in 21? You're going to get how many? 3? Decimal point. We have 30, 6 into 35, 6 into 0, 0. So the second one, 1 kilogram costs $3.50. Let's try the third one and let's see. I know some of you have worked this out already. I know that. 8 into 24. 8 into 0. Aha! Let's look at what we have gotten. In the first instance, 1 kilogram costs $3.60. The second one, $3.50. And the last one, $3. Which one is the best buy? Which person will you go by? The one that has the cheapest rate, $3. This is one that is the best buy. I knew that some of you thought it would have been the first one, and you were fooled. Don't just look at the number there. You have to find for one. Always remember that. And then you will be able to compare. So now that we have compared all three, we see that the best buy is the last one, 8 kilograms for $24. Well done, children. All right, one more challenging question. Are you up to it? Let's try it now. Come with me now. Some objects are weighed as shown below. We have 3 different scales. Are you seeing that? But on each scale, we have identical items. So all the peas are identical, and the packs of flour are identical. Bear that in mind, because that is very, very important. The question says, calculate the mass of the pineapple. Calculate the mass of the pineapple. If this information was given here, it means that we need to use the information above to get to solving the mass of the pineapple. So let's see. What can we use to help us now? Let's look and see. We have 2 identical tins of peas here and 1 sack of flour with a weight of 3 5/10 kilograms. We have 5 identical tins of peas that are weighing the same as 1 sack of flour. Let's stop there. Let's stop there. If the 5 tins of peas, are you seeing it, has the same mass as 1 sack of flour, or 1 pack of flour rather, can I not say that I can put the 5 tins of peas, the mass would be the same? Are you seeing it? Are you seeing that? Wonderful. So in fact, the mass of 5 tins of peas will be equal to the mass of 1 pack of flour. Are you seeing that? Wonderful. If that is the case, can we not replace the mass of 1 pack of flour with the mass of the 5 tins of peas? Wonderful. So we can now say that the mass of 7 tins of peas will be equal to 3 5/10 kilograms. Children, are you seeing that? Are you with me so far? Are you with me so far? Wonderful. What do you think we have to do next? I'm hearing it. We have to find the mass of 1 tin of peas. If we know the mass of 7 tins of peas is equal to 3 5/10 kilograms, can we find the mass of 1? What are we going to do? Do you know what to do? Yes, we are going to divide. Are you with me so far? Wonderful. So let's divide now. What are we going to say? So in truth and in fact, the mass of 1 tin of peas is equal to 5/10 kilograms. Are you seeing that, children? Wonderful. Remember, the mass of each tin of peas is 5/10. We have 2 identical tins of peas. So therefore, we can find the mass of both tins, can we not? Why would we have to do that? Because we want to find the mass of the pack of flour. Now, some of you may say, but I am already seeing that 5 tins of peas, the mass of 5 tins of peas is equal to the mass of 1 pack of flour. And you know what? You are absolutely correct. So if you want to work it out that way, that is just fine. Always remember, there are more than one ways to solve a problem. Wonderful. So let's go back. Let's put the mass of the 2 tins of peas together. 5/10 at 5/10 will give us what? 1 whole. Isn't that so? But what is the weight, or what is the mass rather, of the sack of flour and the mass of the 2 tins of peas together? 3.5, or 3 5/10. So in order to get the mass of the flour, can we not subtract the mass of the 2 tins of peas from the weight given? Let's try it. Remember we said 5/10 at 5/10 will give us 1. So in order to get the mass of the sack of flour, we can say 3 5/10 take away 1. Are you seeing it, children? Wonderful. Remember where we got the 1 kilogram? I'm reminding you now, remember we put the mass of the 2 tins together. 5 tins at 5 tins give us 1. So now the mass of 1 pack of flour will be 2.5 kilograms. Children, are you with me so far? So we are saying that 2 and 5/10 kilogram represents the mass of 1 sack of flour. Now, let's come down. Do you see all the steps involved in solving this? We now know the mass of 1 sack of flour. We found out the mass of 1 tin of peas. That is going to be very important now for this part here. Because remember, what did the question ask us to do? Calculate the mass of the pineapple. Are you seeing the connection? Are you seeing it? If you look carefully, you will see that the mass of 1 pack of flour, the mass of 1 tin of peas, and the mass of 1 pineapple is equal to 7 kilograms. Can we now find the mass of the pineapple? I am seeing you doing it. I am seeing the pencils. Wonderful. Let's go. See if you can solve it before me. What do you think you should do? Very, very good. I can add the mass of the flour, 1 sack of flour, to 1 tin of peas. Are you seeing it here? And then what can I do? Subtract it from the 7 kilograms. And that will give us the mass of the 1 pineapple. Let's do it now. What was it again? Let's go back. What was the mass of 1 pack of flour? Remember, we have 2 and 5/10. Remember, we got 2 and 5/10 kilogram being the mass of 1 pack of flour. Can you remember the mass of 1 tin of peas? Let's look and see. Remember, we calculated it before? 5/10 kilograms. So let's write down that. What did we say we were going to do? To find the mass of the pineapple, we must add the 1 pack of flour to the mass of the 1 tin of peas. Are you seeing it, children? So let's do that now. What will we get? What is our answer? Together, we will get 3 kilograms. Are you seeing that, children? 2 and 5/10 kilogram, add 5/10 kilogram will give us 3 kilograms. Is that the answer? No, it's not. What do we have to do? We have to now subtract that figure from the 7 kilograms here to get the mass of the pineapple. So the mass of the pineapple will be what? Are you working it out? Yes, you are. 7 kilograms, and we will subtract 3 kilograms from that. Children, what is our answer? 4 kilograms. Did you get that? Children, this is an example of a multi-step problem. All you have to do is to read carefully and go through the different steps. And I'm telling you, you will be able to get it. we have come to the end of today's session. I hope that you enjoyed yourself and you really worked out all those problems. Remember, keep on working now. Bye until next time.